So what do you think? How tall is the average NBA player? 6 something. 6'2"? 6'9"? Certainly not 5'6", 5'8", right? Okay. We're going to find that out here in just a moment, or at least get a sampling of data to figure it out. So normal distributions are distributions of data that follow a specific path or pattern. Here's Joseph. They are a bell-shaped curve. The reason we call it a bell-shaped curve is because it kind of looks like a bell upside down, or a bell hanging there. And a couple of things to be aware of. The total area under that bell is 1. Okay, we add up all the percentages all together, we get a total of 1. About 68% of the area lies within 1 standard deviation of the mean. What in the heck was the standard deviation again? What did we do to find that? A lot of steps, right? What was the very first step? We had a whole bunch of data. What did we have to find first in order to start the standard deviation process? Find the mean, okay? Add them all up, divide by however many there are, okay? Once we found that, then we had to find what? Not the median, but take each piece of data, and what did we do? Yep, take away the mean, okay? Every piece of data, we subtracted the mean. And then we squared the difference of all those differences, right? And then what did we do to them? Added them all up and divided by how many there were. And then finally, square root. Okay? So big, long process. Most of the time, we're just going to give you that standard deviation. Make sense? I'm not going to ask you to do that over and over again, especially not with 400 pieces of data. Okay? So that standard deviation is called sigma. Okay? That number is sigma. So mu, the Greek letter mu, looks like a U, is what we would use for our number for the mean. Sigma is however many standard deviations we are away. So this little group here, this right half of the mean to that first mark is going to be mu, our mean, plus a standard deviation away. And mu minus a standard deviation away is what makes up a total of 68% of all of our data. So far, so good? Okay, that means that 34% is 1 standard deviation to the right of the mean, 34% is 1 standard deviation to the left of the mean. Okay, so far, so good? Now we take 2 standard deviations, step it out 2 steps away, and now we're talking about 95% of all of our data lies within 2 standard deviations to the right or to the left of the mean. A big chunk of it. Okay? And then we see our outliers. Mrs. Matheson talked about outliers yesterday. Okay? A lot of times those are 3 standard deviations away or more. Okay? So those are the guys that are on this little cusp of things, the ones that throw your data off if there isn't a lot of data, aren't a lot of pieces of data. Okay? So if you only have 6 tests or six grades in the grade book and you have one that's significantly lower, that will be in that will be one of those outliers, 2 or 3 standard deviations away. Okay? And it can throw you off your whole average. When you have 500 pieces of data and you have one little outlier, it's not going to have as big of an impact. Does that make sense to everybody? Let's know. Okay, so about 99.7% of the area under this curve is within 3 standard deviations of the mean. Okay, and we're going to look at that in just a second. Okay, so here's our NBA All-Star player heights. Okay, there's been a lot of players in the NBA, right? Okay, what are the All-Stars? Who are they? You can name some of them, right? Okay, what's typical of the All-Star players? Does everybody get to be an All-Star player? No, they try to invite, they're not all from the same team, right? They try to invite just a few choice players to play in the All-Star game, right? Okay, so we have only this subset of players, cream of the crop, right? Supposedly the best players from the NBA over time. And Wilt Chamberlain and Kobe Bryant, all, you know, there are some older players in this group. Okay, so it's not just the most current players who are actively playing right now. What does this data kind of look like? It's a bar graph, right? Does it remind you of anything that we were just talking about? A normal distribution, isn't it? For the most part, okay? Where do we have problems with this looking like a bell curve? A little bit high here, isn't it? And a little bit high here. If some of these would fill in here, it could be almost a perfect bell curve, okay? The average height of people tends to fall within a normal distribution. Shoe size of people tends to fall within a normal distribution. Okay, we have 2 normal distributions, one for men and one for women, as far as heights are concerned. Okay, they call it bimodal. Need an extra copy of something. Oh, those are my masters. These are the extra copies. Okay. So this looks like a bell curve, right? Should be one on the right side with his name on it. Maybe not. Maybe I gave it to him. Yeah, I gave him the review. Yeah, that's fine. Not a problem. Okay. So I took this data, 400 and some odd players that have played in the All-Star data, or All-Star team, and I found the average. I did this in Excel because I did not want to add up all those numbers and then divide by however many there were. Okay. I also calculated the standard deviation. So the average height of the NBA All-Stars was 6 feet 6.4 inches. Okay. So certainly not a 5'8" kind of person, 5'7". We're in the 6 foot, 6.5 inch tall player. Okay. Standard deviation was 3.65. 3.65 what? Feet, seconds, minutes, inches, meters, feet. Feet. The average person is, or we have about 68% of them who are within 6 feet, 6.4 inches plus or minus 3.65 feet. We have 9-foot players. No, inches, okay? So your standard deviation is 6.65 inches, okay? So we have a chunk of them that will be within a certain range, okay? So let's look at this. So the mean height of an NBA player is 78.34. When you're filling out a normal curve, you put your mean here, 78.34. Okay, I just converted it to inches. So everybody write 78.34 at the bottom of that curve, in the middle. That's where your mean goes. Everybody got it there? Now, the standard deviation is 3.65 inches. So, what number goes here? Not quite. This is mu. And we need mu plus a sigma. We need to add a standard deviation. So take 78.34 and add 3.65. 81.0 something, right? 81.09? 0.9? Oh, 99. So 82. We're just going to call it 82. Okay. What number goes here? This is our mu minus a sigma. 74.69. Okay. So that's 1 sigma away on both sides. Now we want to go 2 sigmas away. A mu plus 2 sigmas. A mu minus 2 sigmas. Okay, so add another 3.65 to the 82. Take away an 3.365. Thank you. Okay, now we want to go 3 sigmas away. 89.25. 9. And, okay, so this chunk represents 68% of all the NBA All-Star players' heights. 34% are to this side. 34% are to this side of our average, our mean. Okay? What percent lie between 82 and 85.64 inches in height? $13.5, right? Where did we get that number from? A little cheat sheet at the top, right? Okay. 13.5 lie between 71 and 74.69 inches tall. Five or six.
And there's those couple Spud Webs at the other end.
Mm-hmm.
But most basketball players are 6'6". So if you're 5'7", you're not in that bell curve. That Spud Web, you're not gonna get in the NBA. Okay.
Yep. He was and I asked my husband just to see, okay, hun, what do you know about NBA, the NBA? Who's the tallest? And he's like, well, there was some Chinese guy, I can't remember his name. Yao Ming, okay? I said, who's the smallest? And he said Spud Webb. And I said, he's not on my list. And so, oh, he's got to be. He would blah, 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 And then he looked, and he had won a free throw shooting type of thing, but he actually wasn't in this particular list. He was in the NBA, but he wasn't in this particular list because he wasn't an NBA All-Star. And he would be an outlier in that, absolutely. Okay? He was, yeah.
Which, when you looked at him on the court, he looked like he was 4 feet tall because they're so much taller than him
Mm-hmm.
that it was like Steve Nash is like 6'1",
Mm-hmm.
and he looks like a midget out there.
Mm-hmm.
When you see him playing, you're like, he's so short,
Mm-hmm.
but he's 6'1",
Mm-hmm.
and that's not short.
Mm-hmm.
But compared to the 6'6", 6'7", 6'8" that are out there, he looks like he's a tiny little guy.
Right.
And then, yeah, right. Did you see that picture of Kevin Hart standing next to Shaquille and with a Yao too? I mean, you're like, what?
Mm-hmm.
Unbelievable. I actually stood next to some Dallas Stars basketball players in the hotel, and it's freaky. They're like not human. I mean, I was like, his belt buckle,
Mm-hmm.
and I'm like, oh my god, like
Mm-hmm.
how does he get in a car?
Mm-hmm.
Unbelievable. Like you think about it, like yeah, the basketball players now. Giant man.
Mm-hmm.
Right.
Mm-hmm.
It's incredible how big those people are. Just insane.
Yeah, and when I was doing the research on this, they have a WNBA player, a women's NBA player, who is really tall compared to most of the girls, and she would not even, I mean, she would be tiny compared to most of the men NBA players, and doesn't have enough weight. So because she's really tall and has weight, she can push herself around and do really well in the WNBA. They said she wouldn't even sniff the court in the men's NBA, just because they're just huge. So yeah, it's crazy how this is not going to happen. Hate to shoot your dreams down, but not going to happen. But by the same token, you see a gymnast who is my height, and they just look huge compared to all the little gymnasts because gymnastics favors the small, and so forth. Jockeys. I was looking at weights. The average weight, I mean, all of them are like 115 pounds. Grown men, 115 pounds. And if they deviate very much from that 115, they're out. They can't ride the horses. So, and they're very careful about their weight. So, kind of crazy. All right, so everybody's got their bell curve filled out. Okay? And you know what those numbers mean. Okay? All right, so 68% of the players have a height between which two numbers? 68% of the players, what are their heights? Not quite. That's 95%. 95% are between 71.04 and 85.64. How many of them are in that 68% range? Yep, they have heights of 74.69 to 82 inches tall. Okay? So next question, what percent of the players are over 8 foot or 82 inches, which is the same thing as 6 feet 9.5 inches? So what percent of the players are over 82 inches? So just 13.5%? What number's here? Good. That would be right. 16% of them are over 6'9.5". Is everybody reading that correctly? Know where we're getting these numbers from? Okay. What percent of the players are between 71 inches, 5'11", and 74.7 inches, 6 feet 2.5 inches? So which ones are between 71 and 74? What percent? 13.5. Okay. Good. And if I asked you to find this, P parentheses, x less than or equal to mu minus 2 sigma. That's the mathematical form of this. First of all, what does P mean from last chapter? Probability. The probability that our height, whatever we're looking at, right, is less than or equal to the average minus 2 sigmas, okay, 2 standard deviations. What's the probability that someone is the average minus 2 sigmas? Where's the average minus 2 sigmas at? Yep, 71.04. So what's the probability that someone is within this part of this bell curve? Well, if this is 13.5, how much is this block? 2.35, right? How much is this block? 0.15. So 2.35 plus 0.15 is 2.5. So only 2.5% of the NBA All-Stars what? $71. Yep, is under 71 inches. Okay, and 71 inches, how high do we say that was? 5'11". Okay, so only 2.5% of the NBA players, All-Star players, were under 5'11". Okay, I knew I was never going to make it to 5'11 myself, and I would be among the less than 2.5% of the players. Okay, does this make sense? Okay, they're going to expect you to know 34, 34. They're going to expect you to know 13.5, 13.5, 2.5, 2.5, 0.15, 0.15, and what that means. What is mu? Mu plus sigma, mu plus 2 sigmas, mu plus 3 sigmas. What do those mean? Bless you. So I can give you an average, right? And I can give you a standard deviation, and I can give you a chart like this, and you can fill it out. Correct? Math isn't hard, is it? We're just adding numbers.
Like if we give you a mean and the standard deviation, what would your question be? You know where the mean goes on the chart. Where does it go?
The bottom of what?
Middle.
In the middle. Yep. Yep.
Indicates the middle. And then you would add or subtract the standard deviation for each percent. And you need to know that is always 34, 34, 13, 13.5. Okay? Those are always the same. What changes is the numbers you apply.
The numbers in the bottom.
Depending on what, if you're talking about IQs, 100 is in the middle.
Mm-hmm.
The
Shoe size for women is 8.
Yeah, the score for the ACT, the 22 would be in the middle.
Mm-hmm. Okay, so we're looking at the average. All right.